Yeah, if you want to kick it up a bit, let me know when you want to go to the first slide. I'll click it through.
Yep, great. If you go to the first slide. Great. So I'm just going to cover slides summarizing what Tim will actually show you. We're going to show you the sort of things we think are most interesting in this release. Hopefully, most of you may have seen, I think most of you are recognized in terms of SpaceClaim users. V2020 R2 was released 3 or 4 weeks ago. As you probably know, there's various names and versions of SpaceClaim. 3 main ones currently: the original SpaceClaim Engineer, the new product that was out to go with the Discovery technology, Discovery SpaceClaim, same product, different name, different license system, and there is a third one as well, which was predominantly deployed to the ANSYS simulation customers. So at this release, we're consolidating functionality and naming. So for those of you who maybe are on the original SpaceClaim Engineer product, it's still there, it's still working. It's the SpaceClaim organized license system, serial number plus SpaceClaim floating. Just as a heads up, we will be going into legacy on that 1st of Jan 2021. Legacy in ANSYS terms means it's still around, it's still supported for 2 years, but we're going to be encouraging people across to a single version. That single version is focusing on the new name, although it's been named this before, ANSYS SpaceClaim. So those who had maybe been using Discovery SpaceClaim will automatically be moved to ANSYS SpaceClaim. And the consolidation of functionality that I referenced within the ANSYS SpaceClaim product is it includes all the data exchange capabilities. And at this release, we're also adding the facets functionality, which previously was a license add-on. So that tab that you can see along the bottom is the sort of facet capability. It's for manipulation of triangulated data, and some of that terminology probably speaks for itself. Shrink wrapping, you can wrap a mesh over it, you can smooth, you can reduce geometry, triangles, you can do booleans, etc., etc. So anyone who's already got Discovery SpaceClaim may well notice that additional facet tab appear. There is no need to change anything with the licensing, it will just work. This capabilities, some of the things that anyone who's still on SpaceClaim Engineer may be incentivized to look and move across, because there's more functionality for roughly the same sort of money. But again, people like Tim, Chris, myself can explain if anyone's got specific questions about that. The main difference with SpaceClaim Engineer was a serial license, and the equivalent now named ANSYS SpaceClaim is a named user license. It's linked to your email address, and you can have 2 activations per user. So a user could have it at their workstation at work, but you could also, using your work email address, have that, say, at your home device as well. Okay. For those that you don't know, if you wish to download the latest version, if you've got the SpaceClaim Engineer, then myspaceclaim.com is still, which should be a unique one for every user, has one of those where you can download the latest version if you're under maintenance. And for Discovery SpaceClaim, or now called ANSYS SpaceClaim, or the acronym ASC, you go to the Discovery Forum. Okay, next slide, Tim. So functionality of the product. Tim will be showing these next couple of slides. We've introduced constraint-based sketching. Some of you may have been playing with that. It's been in beta and you could have enabled it via the options for the past release or 2, but it's fully supported, fully released now. And again, the tab along the bottom, you can see an additional box of constraints. So we're using the D-cubed constraint modeler from Siemens. And basically within your 2D sketches, you can define relationships. Don't know whether someone could put themselves on mute because there's a bit of background noise, if possible. If anyone's not on mute, appreciate it if you could put yourself on mute. I'm manually doing it for you. Right, hopefully that's done it. And you'll see, as Tim demonstrates this, you'll see obviously what sort of things you can do with it. It allows you to do certain parametric capabilities that with standard SpaceClaim sketching would have been quite awkward, quite difficult. And you can see that it also automatically sets these constraints. So there's a level of intelligence in there. You may or may not want that on. You may want to manually create the constraints to get exactly the operation you want, but those of us playing around with it so far, it seems quite useful, quite helpful that it presumes what sort of constraints you might need. For those of you that don't want to use this in any shape or form, just to note, you can go to the options and return it back to the old, simpler sketch approach, if that's what you like. So, the functionality is there. Use it if it's of benefit. If it's not of benefit for your work, then, as I say, you can switch it off. Next slide, please, Tim. So if this video runs okay, you can just sort of very quickly see the sorts of things you can do. So you create a sketch like on the left, and where you annotate the dimensions, you'll see Tim doing this, those become really driving dimensions. And you can see this quick video is just changing the outer radius of that top left-hand circle between 10 and 12 millimeters. But you notice the distance is defined between the inner and the outer circle is 3 millimeters. So you can see that's consistent, and the other constraints are constraining it within the geometry. So it's keeping the edge of that circle with the horizontal line as perpendicular. Again, to do this sort of operation previously in SpaceClaim would have been very difficult, if not impossible. So that's the sort of capability that you can constrain the sketch. And if Tim presses the next button, the idea is that in combination with this block recording functionality, which you can activate from the Design tab, you can switch on block recording. And if you do that prior to setting up that constrained sketch, as per the example just there, it basically records all the dimensions and allows you to modify those dimensions, such that if you then convert this into 3D, you have really a defining underlying 2D sketch that parameterizes and expose the dimensions that you may want to change and update to 3D design. So the next slide as well, if you can press the button, Tim, shows this sort of example. Same example we saw animating in 2D, but if you have it extruded into 3D, and in this example here, you can see there's some rounds on it, there's a horizontal hole, and in the block recording dialog on the right-hand side, you can see a whole host of dimensions that are basically the 2D annotated dimensions. And if you change those values and really replay that block recording, it will replay that geometry creation from the defining 2D sketch and configure that 3D geometry accordingly. So in essence, you can do full parametric updates with some intelligence with the constrained geometry, putting relationships between various parameters. I haven't seen this myself yet, but we could see some demos of this coming. One of the application areas is connect it to CAD. If you are taking third-party imported CAD, so SolidWorks or Inventor, and that's parametrically defined, and they've exposed those parameters. I think we'll see some examples coming out where you can take that geometry, undertake work in SpaceClaim using this block recording functionality, and flush those parameters back to the defining CAD and update that original CAD SolidWorks file as an example. People have asked us for that sort of capability over the years. This is perceived to deliver that functionality, but I think probably the most common one is to create more involved parametric changes, maybe setting geometry up for optimization loops. Those are the sort of things we see the most common demands where we've been asked for this in the past. Next slide, Tim. Okay, various file updates. I think we missed the first slide, or the second slide, Tim, which listed a few other things, but let's not worry. Let's just, I can always show that at the end, but let's jump to the demo and show that sort of capability we've just been running through, and then we'll come back and we'll show the enhancements or the changes in the discovery side of the product.
Yeah, no worries. Okay. Can you still see my screen, Peter?
I can indeed, yep.
Yeah, perfect. Okay, so if you've downloaded the new latest release, hopefully you'll be seeing the new sketch tab in the left-hand side. Previously, you would have seen your sort of sketch tools in the design tab, but now they're all in the sketch tab. All the tools that you knew before will all be here. The only thing that's new is obviously these constraints. Again, as Peter mentioned, this can be turned off if you don't like them, and you can go back to the default way of working. But this is going to just give you an overview of how they work and basically how to hopefully use them and some sort of best practices. So they're meant to be used in conjunction with block recording. So basically you click on blocks, and then in a few seconds we should see a panel appear on our right hand side. So we can see a panel on our right hand side here, and from there we'll click sketch mode, and we'll choose an axis to sketch off. I'm just going to choose the Y, and that'll just drop a sketch onto that Y axis. I'm just going to go into a plan view. Always nice to sketch in a plan view. And literally, just going to start with a simple rectangle. One thing when we're creating these sketches, we are automatically creating constraints. If you don't want to, and you want to manually apply constraints, you can always turn that off. But I'm just going to click a rectangle and basically draw a rectangle. Don't worry about what the size is, because that's not important at the moment. We will show you how that can be changed. What you will notice here, hopefully, is that there's two colours, two different colour lines. So we've got a teal colour and a blue colour. Blue is a fully constrained line, and teal is a partially constrained line. So what that means is the teal colour lines can be moved. The blue colour lines, they're constrained, they can't be moved at the moment. To actually highlight and show your constraints, you have this little blue I button up here, so this will show your constraint tips, and then you can click these drop downs, and you can click on these, and you can basically see the actual constraints that you're using. Another thing you can do is you can click on the actual lines themselves. You'll get this, and you can actually remove constraints if you wish. So you can see, obviously, this is a constraint there that's locking to that point. If we didn't want it to, we can remove those constraints literally just by deleting them, by clicking on it here. I'm just going to fully constrain this rectangle by basically adding 2 dimensions. So I'm going to add a dimension to the length and the dimension to the width. And as I've added those 2 dimensions, you can see hopefully the lines have now all gone blue. We can drive our model via these dimensions. So we can type in values, and I'm just going to type in 40 and 60. And hopefully you can see the model update as we type in those dimensions. That's something we could do previously in SpaceClaim without using like a full tool or something. Then we can carry on sketching. So first of all, because the part I'm going to create is a symmetrical part, I'm just going to draw a construction line going down the centre of the part. And hopefully you're aware of this, but if you right click on any line or construction line in SpaceClaim, you can set it as a mirror line. So once that's been added, we can see that one of the lines actually turned to red. That means it's sort of over constrained or fully constrained. Again, we can just remove a constraint, and we can just delete some of the constraint that would be causing it to be fully constrained. So I've just deleted those 2 constraints because it won't matter at the moment, because I'll be constraining the model later on. And I'm just going to carry on and do some further sketching. So I'm going to draw a circle here, and you can add your values as you go along. I'm going to draw a rectangle here. I'm just going to just eyeball it there. I'm going to draw a line going from somewhere along here. As I say, we can always add dimensions and stuff to be constrained afterwards. So let's say 60 degrees, something like that. And I'm also going to use my offset curve tool. So all the tools you're familiar with, obviously, all still work in this mode. And I'm going to offset those by 3 mil. And then I'm going to add just another circle. Again, we can date them using the shift key. And I want that to be, let's say, 15 and 15. And I'm going to say 10 mil. So I've got my my sketch drawn now, but I'm going to start constraining it. I might want to make some changes. I might want to check some dimensions. First of all, I'm literally going to just trim away all the excess lines I don't need anymore. And just literally trim away these lines. So we can see our sketch is now as it is. Nothing's fully constrained. No blue no blue lines anymore, or teal coloured, so it shows that it's not constrained. If I use my select tool, you can see we can move this around as we see fit. There's nothing's constrained. I'm just going to just remove this dimension, because obviously that's not one that we need anymore. So literally hit the delete key. There we go. And I'm just going to start adding some dimensions to actually constrain this model. So the first one I'm going to do is the height. And I'm just going to just literally dimension it there. I'm going to dimension the radius of this. I'm going to dimension the offset between them. And as I'm dimensioning these, hopefully you'll see the lines turn blue. So I'm going to dimension this mill here. I'm going to dimension that distance there. And I'm going to dimension this distance here. I'm going to dimension the height of this to here. Again, don't worry about the neatness of it, it doesn't overly matter. And I'm going to constrain the distance from here to here. And that distance from there to there. As you constrain the model, hopefully you'll see it just starts to turn blue. You can also add your own constraints, like you can add fixed constraints to the model. Such as this line, for example, if I want this line to be fixed, we can add them manually as well. So no reason why you can't add constraints manually. Clicking on a fixed constraint, I want to fix this line here, and that's now a fixed constraint. There's going to be a few more constraints I want to add to the model. Just something that's going to constrain these circles, and the way that we do that is I just want to measure the 15 mil from the centers to the walls, and then add 10. So I'm just adding those as I go. Once you're sort of happy with your sketch, what you can then do is, obviously, as I said, you can modify things. So if I don't like the distance here, I can make a change. I want that to be 25, and the model will update. And you can see the model update, and all the other ones stay the same. Once you're happy with your sort of sketch and you've got all your constraints that you want in the model, you can constrain or leave parts as constrained as much as you want. It's totally up to you how you do this. But once you're happy with the sketch, you can hit the end sketch editing tool, or you can go into a pull mode like you would normally. Once you click this, it'll take you into 3D mode, as we normally would see in SpaceClaim. We get a surface now where our curves were. But if we look to the right-hand side, we've now got a block. We call that a block, the sketch block, where we can jump back to that sketch. If we actually open it up, these are all the parameters that I've just set. So, for example, I knew the distance between here and here was 25. I know that distance. I know the hole was 10 mil, this hole here. So we can modify them from this actual panel here, or we can click this tool here to actually go back into and edit that sketch and make any changes you wish. So I'm just going to end that sketch editing, and then we're going to carry on going into sort of do a few 3D modifications. So the first one we're going to do, I'm just going to extrude it. Literally just do a pull, and again, you notice I don't add any dimensions here because I can always add more parameters later if I need to change them. I'm going to click on this space here, and I'm going to go back into a sketch mode, and I want to draw a circle here, and I might have, let's say, a 7.5 mil circle there. If I want to actually modify that circle potentially later on, or potentially a different variation or version of this model has a slightly different hole here, I add my dimension and literally end the sketch editing. We'll see another sketch here, and we can see our dimension appear there, which can be modified there. I'm going to do a simple pull as a cut through that model. And every step that I do, hopefully you can see it create a new block. And also if you hover over it, you will see like a little preview of the step. One last thing we'll do before we actually change some of these parameters and update the model is we're going to just create another cut. Select on these two areas, again go into a sketch mode and look at it from plan view and click on the rectangle tool, and I'm just going to just draw Control Z, I'll undo that, and draw a rectangle as such. You can see this is again pretty much fully constrained over the length here. That's the only thing that isn't constrained. I'm not going to bother adding any dimensions here, but again, hopefully you can see that this would need to be changed later on. End sketch editing, and I'm just going to do a pull in both directions, make sure it's a cut, and just slice through the model as such. So we've just created a fairly simple model. I'll go further and make more modifications, and we'll see more steps appear in our block recording area. But I just wanted to just obviously show you then obviously making changes to the model via these areas and rebuilding the model. And that's obviously something not nice and neat to show. So obviously this would be great for if you've got different variations of models, slightly different sizes, that sort of thing. This sort of feature hopefully would be useful for that sort of stuff. So now if we wanted to make some modifications, I might think actually that dimension from here to here was 25. Let's make that actually 20. This whole size was 10. Let's make that 12. I might do actually the extrude face is 14.3. I want that to be 15. Well, let's go bigger, 17.5. So what you'll see as we add these things in, you'll see a little sort of lightning bolt, and that basically is just telling you that the model needs to be updated for these changes to take effect. So again, I might make this 8 mil, and I might be happy with those changes. Obviously, the model hasn't updated just yet, so to update the model with these effects I've made, you literally just hit this little play button here in the top right-hand corner, and the model will basically rebuild with those new steps that I've created. So you can see the model's rebuilt fairly quickly. We've now got 12 mil hole, and obviously the thickness. What I put it at 17.5. This hole should be now 8 mil. So there's all those changes, and hopefully we saw the model update. Again, you can jump back to any step that you wish. If you thought, okay, actually I want to go back and change that sketch quite radically, you can move to right click, move to that stage, and start changing the sketch yourself. Or you click this button down here and actually start editing the sketch, and you can make whatever changes you want to make there. So that's just a very quick demo of sort of how this tool is meant to be used. What I'll show you now is just so you know, you can obviously add these constraints manually. I'm just going to quickly draw a very basic random lines. So we can see we've got 4 lines there. None of them are constrained. Obviously, if you hover over these things, they will tell you what they do. If I want to make that line there parallel with this line, and this line here parallel with this line, we can start to do that sort of stuff. If you want to make a perpendicular constraint, I can add a perpendicular constraint. Now remember, hit this little eye tool here, the constraints will appear, and you can click on an area and you can see what constraints are on a line. You can start to see these constraints appear. So that's how that tool basically works. Hopefully that's a bit of a better idea of how to use it and mainly best practices. As Peter mentioned, if you don't like it, it's up to you whether you use it or not. You can turn it back on to the default SpaceClaim mode, and the way that you do that is just go to File, SpaceClaim Options, and Advanced, and you've got this Enable Constraint-Based Sketching here. So untick that, restart your SpaceClaim, and your sketch tool will default back to the Design tab as you may have been used to working. So hopefully that's just giving you a bit of an idea of how to use the sketch-based constraints. There's obviously a lot more that you can do with it. That was just a sort of 5-10 minute demo, and hopefully that's just giving you a bit of a better idea of the new feature. And it's quite a new feature in SpaceClaim. It's obviously you're not aware how to use it. It might confuse you a little bit. Do you want to take over again, Peter?
Yep, sure. If you pull up the slides for me.
Okay.
And can you just go back to the second slide because we missed it?
This one.
Yeah. So very quickly, just a few other items. other things we've added, the auto skinning functionality, which came in at the last release, we can do it with nerve face preservation. I think that's something Tim and I would have shown, but we haven't had a demo for it yet. But it basically allows you to combine the conversion of organic faceted data with sort of maybe the boundary or the NURB representation you want. So if you've got a bolt hole, say, for a component and the rest of it's organic, you need a pure cylinder on that bolt hole. So it's quite a nice enhancement to auto skinning. And I think in the webinar that will come from corporate towards the end of August, that will probably be demonstrated. A few other things, just enhancing the usual stuff, imprinting, volume extract improvements. Support for external document looks interesting, but again, apologies, we haven't got a demo for that yet. If you just move down to slide 8 on this slide deck. So this potentially looks interesting in so much as, again, if you're a user, and we've had questions from many users over the years where you're loading in assembly documents with subcomponents from third-party geometry, looks like they've done some work in that area to more effectively maintain the assembly structure and have multiple users working on an assembly and keeping the management of that manageable. As I say, we haven't really seen a working example of that yet, but the ANSYS webinar at the end of August should be demonstrating that if you wish to sign up to that. If you drop down the next slide or two slides down. Yeah, one more. So we were going to cover Discovery. For those of you that aren't aware, Discovery came out about 2 years ago, and there were 2 versions of it, a product called Discovery Live and Discovery AIM. The R2020 R2 release, there's just a single name, ANSYS Discovery, and ANSYS Live, every ANSYS Live customer gets the ANSYS Discovery interface, and any customers that had ANSYS AIM, Discovery AIM, has options to choose either mechanical or fluids examples. We're going to keep this relatively short. Some of you may not have this functionality at all, but it is very interesting capability. The idea and the aspiration, and the reason it's been embedded within SpaceClaim, is to get simulation in the hands of designers. If you're a simulation expert, you can use a variety of tools, ANSYS tools or third-party tools. The majority of them are aimed at and provide capability for the experienced simulation expert, and your designer often struggles to utilize those high-end advanced tools. What ANSYS is attempting to do is deliver designer-friendly simulation capabilities so that as you're designing a product, you can get rapid guidance on whether your performance is going to be in the domain that you require. The 2 versions, the sort of GPU accelerated version, which was ANSYS Live, and the high fidelity version, which was ANSYS AIM, is now covered in one product. So a single interface. It basically makes the transition from instantaneous GPU simulation to high fidelity simulation a click of a button. It doesn't necessarily, obviously the high fidelity simulation obviously takes a longer cycle, the more common cycle people are aware of with FEA, CFD, going through a mesh generation process, and then the actual results. And so Tim's going to give you a quick demo on this anyway, for those of you who haven't seen it, or for the users that are on board as well. This will give you a heads up of this capability. If you can go to the next slide, Tim. So when I say GPU accelerated simulation, so I'm sure you probably all know on your standard machine, you have a CPU, central processing unit, and a GPU, graphics processing unit. We specifically support NVIDIA GPU graphics cards. And if a graphics card's got 500 cores or 1,000 or 2,000 or 4,000 cores, whereas your average CPU will be 2, 4, 6, 16, some up to 64 these days, you can see that literally the number of cores in a GPU accelerates away from what's available on CPU. And GPU architectures are very focused on being able to effectively process parallel calculations. Unfortunately, CAD isn't very parallelized, so that's why you don't see CAD products running on GPUs, because it can take no advantage of the parallelization. But for something like simulation, which is very effective at parallelizing, it's a great deployment architecture for accelerating the processing task by sharing that across the cores and being able to run in parallel. So the Discovery product, which was called Discovery Live, is shown on the left. It basically gives you instantaneous physics. Tim's going to demo it, and you see results coming back within seconds. And then at the flick of the switch, we'll perhaps towards the end show you just how easy it is to switch that across to the high fidelity physics, where you basically can also on that screenshot see the mesh representation and the complexity of that mesh, the time it takes to create it, and then the time to solve this. And you're back on typically on CPU processing, which you can parallelize if you have an HPC system, but you'll see, the one on the left will take seconds, the one on the right is going to take minutes to tens of minutes. The aspiration is that people get to see with the instant physics a good representation and understanding, a ballpark capability of how that geometry is performing. Yet if they need that high fidelity solution as well, that's available it is a license option, so it's a cost option, but both are available within the same interface. Next slide, please, Tim. We think it's a very interesting user interface. You'll see it in a minute, and it has things like in-context help, where you're hovering over within the graphics scene and just hit F1 and you'll get this context help that comes up and explains what you're doing. And the whole idea is to guide the designer through the setup of a simulation process in layman's terms, so that they can not necessarily be that simulation expert and be able to get a good result back from that capability. And then at the same time, having set your problem up, got an answer in seconds, maybe if they need to dive in deeper, control the mesh in greater granularity, if geometry determines that you need a different mesh representation, if you need different boundary conditions or limits on your simulation, all of that capability is available in the analyze mode. So in the bottom dialog, you can see three modes. There's a model mode, which is basically SpaceClaim type modeling. There's an explore mode, which is the GPU accelerated instantaneous simulation, and then there's the analyze mode, which is the high fidelity. And we cover finite element analysis, modal analysis, computational fluid dynamics, thermal analysis, and generative design being topology optimization. And I think that's the example that Tim's going to do, a quick FEA and generative design example. Okay, Tim, would you like to jump into that?
Yeah, but I do not want to show this one as necessary.
I'll come back to that at the end if it's relevant.
Okay, let me just fire it up, which should take a few seconds.
So I'll read off that slide while it's firing up, actually. So again, a bit like SpaceClaim, but more specifically at V2020R2, that was the last release of Discovery Live and Discovery AIM. Again, it's gone into legacy mode. Again, ANSYS's legacy procedure is at least 2 years, so the product's around. There may well be updates to it if anything critical is required. But this new Discovery interface, which is about to fire up, is the step forward, and we hope and expect most customers to move forward to that and start using that as their go forward product. There are some limitations. Not all of the functionality in Discovery AIM is available in this release of Discovery, but we have various sort of product plans for the next release in January to cover a lot of that ground that wasn't implemented, and then the release after that to hopefully catch up and deliver most of that capability. So if there's any questions about that, again, come back to Tim or myself, ask whatever you want about your own requirement if you have a Discovery Live or a Discovery AIM version. Okay, over to you, Tim.
Yep. Can you see my screen still?
Yes. Yes.
I think, can you hear me?
Yes. I can hear you, Tim.
I think you keep muting me, sorry. Okay, so this is the Discovery Live interface. This is the first thing you'll see if you open up Discovery. Sorry, I said Discovery Live there. This is just Discovery product. So from here, you can see your recent files, your sample files, and also got a nice learn thing. So the learn thing shows you welcome screen. Also, you can do an interactive tour, and you can click through it, which is quite nice. I won't show you all this because we haven't got time to spend loads of time on that sort of thing. But if we go back to the home page, also you've got a welcome screen, and this just shows you nice little videos and neat features how to use the product basically. But we're going to open up one of these models, so I'm going to double click and let that one load up. And as with SpaceClaim, this and Discovery and previous Discovery products, we can read and write pretty much most CAD formats, so you won't have any issue importing data into this product. And hopefully, again, you can see it's a very similar layout to the other products, Live and SpaceClaim. So along the top, you've got your tabs, you've got your design tabs that you'll be familiar with, your facets tab, your display tab, measure tab, prepare tab, and your simulation tab. So we're going to just do a very quick structural simulation, and then we're going to do a bit of a very quick topology optimization on that part. The part that we're interested in is the white part. So to focus on the white part only, we can right click on it and we can make sure that we solve the physics on this selection only. And just to clear out any of the noise, I'm actually just going to right click and say hide others just for the time being. So we're just focused on this one part. You can always turn it on afterwards. So the first thing we could do, if you want to change the material, you've got your material settings here. At the moment, it's set to structural steel. If I double click, I can choose a material, it's presets, or I can use the defined. I can set my own materials as well. I'm just going to, let's say, select aluminium, and we're going to go from there. So the first thing we've set up a structural simulation is we need to apply some sort of fixed supports. So holding control, I'm literally just going to select on where I know that the fixed supports are. So just these 7 holes holding control. And once I've done that, we can again use the bars at the top. We can click on structural, we can add supports, just to show you that. We can do that from here. Or we can click on the hexagonal pop-up bar here, a little interactive bar, and we get our little radial menu. And this obviously I'm looking for a structural simulation, so I can click on this, and if I hover over these, obviously it'll tell me what they are. So obviously in this instance, I wanted to add some supports to those areas. So if I'm happy with the supports that added, I'll just hit the tick box and accept. And that'll add almost fixed supports to those areas. As Peter mentioned, if you hit the F1 key, you get this sort of interactive help guide. First of all, you get your little video panel at the top. You might not be able to see it, we've got that in the way. A little video in the top right hand corner, and left hand side again telling you a little bit more information. As I actually hover over these individual things, it actually gives us a bit of a guide of actually what these individual buttons do and the picture mean. So that's what's quite neat, and the help guide very whenever you want, press F1 and it will give you interactive help on the model that you're actually working on. When you want to close that, you just hit the little X button in the top right hand corner, make sure it's not the white one, the little red one, and that'll just close the interactive help. So I've added my my fixed supports, so I'm going to hit the escape key twice, and now I'm going to apply some forces to the model. So again, similar sort of thing. I know where the forces are going to be applied. Holding control, and I've selected the holes where the force is going to be applied. Click on my interactive bar again, click on my structural one, and this time I'm going to apply a force. I know it's this button here. And then you've got all your different types of force. So I'm going to use, in this instance, I'm going to use a remote point. I'm going to use a remote point, and I'm going to click this little arrows here just to apply the force in a certain area. So I only want the force in the Z direction, because I know that's where the force is going to be applied. So I'm going to make sure the X and the Y are both set to 0. And obviously Z can stay as it is. And then the force that I want on in the Z direction is going to be minus 200. It's going down. The Z direction is going down. And then I can hit the enter button. And that'll apply that force. And hopefully you can see now the force is going in the Z direction, obviously in the minus direction. Again, once we're happy with that, we can hit the escape key twice. So I've now applied a force, applied fixed force to this model, and we are in the explore stage at the moment. So we've got the model stage, the explore stage, and the analyze stage. In the explore stage, we can set our fidelity bar here. We can drag this up, lower this, and I'm going to keep it here for the time being, just for the purpose of the demo. But once you've got that set up there, you can basically move over to your right-hand corner, and you can see you've got a little power button, a little green power button. This is the solve button. And you can hit that green solve button, and within a few seconds you're going to start to get results. So this is obviously what live used to do. So instantly we've got results. At the moment we're looking at displacement. We can actually show the displacement, and we can animate it as well if we wish, just by using these interactive bars down here. Just turn those off. But we can also look for other things such as from modulus stress. We can show those there. We can mess around with the values here, maximum and max. We can also show charts, factor of safety. Obviously, that's an improvement added to it, which I don't think Live did have before, so it's now factor of safety. So you can show your charts as well and create other charts. So just very quickly, we've got a simulation, we've got results, and we can now potentially move on and improve areas where there might be too high strains and stresses. But in this instance, we're going to do a topology optimization of this part based on the fixed supports and forces that I've added. So to do a topology optimization, you can literally click on the topology optimization button. And you'll see, if I just, because the part's white, it's a little bit hard to see, sorry about that. But yeah, you've got your topology optimization control panel basically pops up. So the first thing is what we're looking to achieve, maximize stiffness, remove material, maximize natural frequency. You can see these different options of what we're trying to achieve. In this instance, I'm going to go with maximize stiffness. And then we've got a volume reduction. So how much volume do we want to reduce from the original part? I'm going to say 30%. And then what we call here the projected distance is basically wherever we've got fixed supports or forces, that's the boundary, that's what it's not going to, the simulation or the solver isn't going to work on those protected areas. We can see at the moment, obviously, it's set to meters, that can all be changed, and we can change our to whichever we want. So once we've got all our settings, we're happy with all our settings, again, I'm just going to hit the escape key twice. We know we're in topology optimization mode now, so we can see it here. And again, we literally can just hit the solve button. Obviously, one thing to note, you could have defeatured this model, added area, but to give it a bit more workspace, we call it, when we're optimizing. But for demo purposes, we're not going to go too detailed into this optimization. But we're happy with our settings. We're going to hit the solve button, and we will literally see, sort of in front of our eyes, the parts start to reduce in volume. So it'll go through sort of different iterations, and hopefully you can see the first iteration, it's lost a certain amount of volume. And the part is now doing its optimization based on the settings that I've so trying to reduce the mass by about 30%. And you'll know when it gets to a certain point where basically the model doesn't really change much anymore. So once it gets to that point, you can stop the solver, but just by pressing the pause button. and then we'll take it from there. We'll just let it go through a couple more iterations, and then we'll hit the pause button. So I'm going to leave it at that. I'm going to say I'm happy with that for the moment. So I'm just going to hit the pause button. And obviously, again, it's still analysing the model. I'm actually going to then add my optimised body to the model. So what that'll do is it'll convert this result into an STL. So literally just by clicking this button, we'll get our result. And we can see now, I'm just going to turn off the actual contour so we can see we've now got an STL body of our optimised shape. So what we can now do with that STL is in our tree, this is basically our sort of structure tree, you can say. This is our different components. So this is the facets that I've got. If I right click on that, we can, one, smooth the facets if you think you want, okay, I might actually use this, might 3D printing, but I want like a more aesthetically and more smoother model. We can actually smooth the facets, and it's going to take a few seconds. If my screen goes black, just wait for about 10 seconds and we will get a result. So hopefully see my model now on my screen again, but you'll just see that we've got a much more smoother result, more aesthetically pleasing. And we might then, obviously, once we've got our result, want to actually create a validation solution on that result. So we actually now want to go in and validate, make sure it does all meet the requirements that we've set previously with our simulation. So we can right click on it and we can create a validation simulation. So that again will take all the presets, the supports, and the forces that I've previously applied and apply them to this model. So that's applied this model now. We can start to see our fixed supports and our forces. And again, we literally can hit the solve button. And the model will start solving. What I like to do is just turn off my actual facets or the triangles, so I don't actually see all the individual triangles. So if I go to the facets tab and just turn off, or just tick these here on the right hand side, you can see a bit of a cleaner model. So again, now we've just run a simulation on our optimized part. Again, you can study, you can add charts, different calculations, you've got all different factors of safety, make sure it's meeting a certain standard on the new optimized part, just to ensure that we again just meet all the criteria. But yeah, that's just a very, very quick demo on how you can do a very quick structural simulation, take that simulation part, optimize it, and then validate your solution afterwards. And if I just turn on the part, we can see how it again fits with our assembly. So that's just a very quick one. As Peter mentioned, if you want to then go on a deeper exploration of the part, you can go into analyze mode, which is here. In analyze mode, you can again you'll get like different warnings. So I'm not sure why that one's saying that. Definitely got a license. You can see where it says if the surface bodies and that will be excluded from the simulation and things like that. So you get messages to warn you if there's anything going to be missing. But in the analyze mode, again, you can start to look at different simulations and actually analyze it in a lot more detail, so you can actually mesh the model. We won't do that in this demo, unfortunately, just because we won't have the time. But in the analyze stage, you will be able to fully define the model and actually mesh it, and you can get your global mesh settings or local mesh settings to actually mesh it how you wish. But you can then get what we say higher fidelity results, or just to double check your results in a more advanced simulation. That's pretty much the demo, basically. Is there anything you want to add to that feature? Or is there anything on this that you think would be useful to show?
No, obviously 10-15 minutes is a bit short to show it in great depth. But compared with Discovery Live, I think there's just more guidance. You didn't point it out, but when you went to the factor of safety, it had a red down arrow, which was just an indication that you had decreased the factor of safety as we had removed material, which of course makes sense. But the whole idea of the product is to try to give input to the designer without them having to sit and calculate and understand these things. And from my perspective, I'm slightly biased, of course. I think it's doing quite a nice job compared with, say, the first release of Discovery Live, which was interesting in terms of what it could produce. But I think they've really stepped up the guidance and the user interface interaction that this provides. So hopefully, for those of you that have got Live, we're hoping that you see this as a very good and positive step. Right, we have done 50 minutes, so we said we were going to do 45, I think, didn't we, Tim? I'll quickly unmute everyone. It's only a small group, so I don't know if anyone's got any questions. Was there anything that anyone wanted to ask? I know, Richard, your microphone's not working, but you're welcome to type, or if anyone wants to ask a question, feel free to ask now. Yep. Silence from the audience.
Yep, we're okay then. I mean, let's say if anyone wants to drop us an email, if anyone's got any questions on either of the products or you want to just go over anything again, we're happy to do personalised web sessions with anyone. So just let me know by the email and call my email address, and we can do personalised web sessions and that sort of stuff as well.
Good stuff. Okay, well, thanks for everyone attending, and we look forward to hearing from you.
Cheers, guys.
Thank you.
Take care. Bye-bye.
Cheers, bye.
Bye.